Now we're going to apply these rules for significant figures and calculations because, ultimately science needs a lot of calculations. Before we do that, though, we're going to talk about rounding, so how to round some numbers. This should not be anything too new, but just wanted to make sure we're clear about how this works. First of all, we're going to round at a specific digit, and that's very frequently is going to happen. We're going to find a specific digit and then look to the right of it, and basically round down if it's the digit to the right is from 0 to 4, or round up if the digit is from 5 to 9. That is to the right of the one that you want. So for each of these right here, I'm going to give you guys a chance to round to 3 significant figures. I'll do the first 2 with you. This first one right here, 0.393, right? So I want to round here, right? So at least that's the digit I want to keep. Looking to the right of it, 2 is going to make that 3 stay where it's at. So this one, your correct rounding, wound up being 0.393. Remember, if you're thinking this 0 in front is supposed to be kept, that's an insignificant value because it's a leading 0. The second one here, right, 0.08, blah, 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 blah. So looking at this one more time, leading zeros, right, 0.0. Again, this is after decimal place, sure, but it's after, it's not a trailing 0. And so we want to round this based on this digit right here, right? We want to keep that third digit, right? The second 0, third digit. And as a result, because the 0 next to it, right, is from 0 to 4, that's going to keep 0.0800 right there as your rounded value. Try out the rest of them here. You see the answers at the bottom. And then number 6 is a little bit tricky, but I think you'll have a chance to try it out on your own first, which makes it make more sense when we come together and discuss it. As a rule, calculations, when we actually do calculations, you're going to get a lot of different numbers out of your calculator, but we have to round it accordingly. And so to round it, or to finally get our answers, we look at the value generally with the least significance that we started with, and then your final answer will match that. So whatever you start with, look at those, and then your final answer will match it. Addition and subtraction, those are going to have different rules than multiplication and division. Hopefully you kind of get a sense that those are like kind of different families, different types of calculations. So those will stay together. And as always, we all follow the order of operations. You might have learned it in different ways, but PEMDAS, right? PE is for powers, or in parentheses, and exponents. M and D are multiplication, division. A and S, those represent addition, subtraction. So they're kind of already in that order. You always do these first, then you do these, and then you do these in that order. Now the key is, though, if you change that type of calculation, right, especially when it comes to between here and here, between multiplication, division, and then addition, subtraction, you've got to change, or you've got to do the rounding and then continue. Now, that doesn't make any sense in the abstract. We'll see that example in just a little while. First of all, let's talk about addition and subtraction. Now, these rules right here, let's be very clear, has very slightly nuanced terminology that's different, but, it's important. So for addition and subtraction, you always have your final calculated value is going to have the same precision as the original values with the least precision, right? So precision, if you remember, that's about the number of decimal places. Which one has the fewest decimal places? So in this case, my example is 1.03, 94.1, 0.00318, and your calculator will give you 95.13318. All right, now, this is not the final answer I can report. This is just what my calculator gives me. I have to look back at my original values, 1.03, 94.1, blah, 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 and look at the precision of each of these. So this one has the precision down to 2 decimal places. This one has a precision down to 1 decimal place. This one has precision all the way down to the 100,000th place. So looking at these 3, which one has the least amount of precision? It's going to be this one right here that I've already gotten the arrow drawn to, this value anyway. So because this one has the least precision, my final answer has to match that level of precision. I can't go any further. So if you kind of imagine, right, this would be the one that corresponds to this guy, right? That one carries there. This one would correspond all the way down to here. But the important one is that this one corresponds down to this one, the 95.1, right, the 10th place, the first decimal place. So around there, 95.13317 something rounds just to 95.1, and that's it. Some of you might find it helpful to use like an old school method where you pretty much write it out, kind of using the line by line, and then you sort of do it based on the kind of like where the decimal places line up and stuff like that. So you could do it like this right here, and when you do the calculation, again, it's going to be the same value, 13318 there, but you would use that's kind of visual here to help you kind of see where you would round accordingly. And so based on this sort of visual, I would actually go ahead and round it to 95.1 in that way instead of having to count it out. It's up to you. I think you'll find it much more effective, especially when you're kind of get moving on these, to do it the original way. But to, again, conceptualize it, it might be helpful to think of it as like this old school calculation that you might have done in the past. So going back to this idea of why we need to care about this. Well, first of all, let's return to our two scales that we had from before. I'm going to weigh a bunch of apples. Your friend weighs a bunch of apples, and different apples anyway. And so my scale that I have to start with reads to the thousandths place, right? So it's 6.293. So I have my own little sample of apples, and I toss it on there. The other scale, your friend's scale, only reads to the tenths place, so 94.5 there. So if I were asked anyway to report the total mass or the total weight of all of these apples, right, what would you report? Well, again, it kind of makes sense that, you just throw these two together, but you have to be careful about how you report it because that's where the significance comes in. That's where significant figures comes in. If you plug it in your calculator, you'll get 10.793 pounds. But I can't really report that because the precision of the second scale only goes down to the tenths place, right? It's not super precise. And so what comes after here isn't necessarily 0 and 0. I just didn't have a scale that could tell me about those numbers. So assuming it's 0 and 0 is actually very dangerous. That's not something that science allows. That does not report the appropriate amount of precision. So when you have 10.793, I actually can't report anything past the tenths place right there, right? Because my second value here, that one's only precise down at the tenths place. The first one has a lot more precision, but the second one doesn't, so my final answer then would have to be reported accordingly. It'll end up being 10.8 pounds. And this is the best answer that I can provide for the question, what is the total weight of my apples? Here's some practice. You go and see that you have 5 examples. In the very bottom, there's got some answers for you to double check against. So go ahead and try those out, and we'll check those out later on. Next one, multiplication and division. All right, now for this one, you're going to actually look at the definition and find that's almost identical. It's very similar, except the one key difference is that when our final answer is to be reported, you will have the same number of significant figures as original values with the fewest sig figs. All right, now remember, this is different than the original, or the first one anyway, the addition subtraction one. That one says precision, which is based on the fewest number of decimal places. This one is about significant figures. So this one we actually look at the number as a whole and then decide on how many significant figures it has. So let's try this out with the example. 1.03, same numbers honestly as the previous example with the addition subtraction. And we'll stick these numbers in a calculator. Okay, so in our calculators we get 0.30821,514, so on and so forth. All right. How do we round this number as a final answer? Well, again, based on what we saw previously, or at least with this definition, we're looking at the number of sig figs. So our general rule for sig figs, or at least my kind of pattern, is that I will write the number of sig figs above each of the values just to remind myself of what they are. So 1.03, that's 3 significant figures. 94.1, that's 3.00318. That's also 3 significant figures. So I'm going to go ahead and compare those numbers. 3 versus 3 sig figs versus 3 significant figures. Which one has the least number of significant figures? All of them have the same number, so there's not really a least per se. It's just going to be 3. So looking at my number here, I'm going to round at the right there, so 0.308, because 8 is the third significant figure in my calculated answer. So my final answer will be reported as just 0.308, because that 2 rounds the 8 down to 8. So that's your final answer. I have to be very, very careful about this because remember, this is not the same thing as the number of decimal places, which refers to precision. This is about the number of significant figures, which, again, it sounds kind of similar at first, but I beseech you to pay attention to that difference. We'll use them accordingly. All right. You have a practice problem here, a couple of them anyway. Once more, double check your work at the bottom. All right, now we're talking about the mixing of calculations. And once again, as a reminder, PEMDAS is written up there, right? So parentheses, stuff in parentheses, stuff that's going to be in exponents and so on and so forth. So let's make sure that we're clear about what that refers to. I am asking you again to be careful when you change the type. So looking at this, 44.03, 103, so on and so forth. This first example right here, how would you perform this? Well, you would first do this calculation here. Right, and then secondly, you would do this calculation. Whatever the result is from here, you then add it to 44.03. So let's see what that calculation looks like. Now, What I cannot do, and I'm just going to stop you right here if you're trying to do that. What I cannot do is go ahead and stick this whole thing in my calculator and figure out a number once I press enter. Right? I actually have to break this down step by step. Let's see what that looks like. So 103 times 0.39. Notice how I kept the points and whatever there as much as possible. The resulting calculation from that in my calculator is 40.17. So what I then did is went ahead and rounded accordingly to remind yourselves of what's up. This is going to be multiplication and division. So look at the number of significant figures. That's 3 and 2. Remember that 2 I didn't get from the fact that there's 2 decimal places, but the fact that there's just 2 significant figures, right? And then when I round it down here, I look at the fact that this keeps me with 2 significant figures, and I round everything else away. All right, so the result of this calculation is 40. Now, the reason why I do it here, as a reminder, is that I'm then going to add it to the 44.03. So this calculation is going to be an addition and or subtraction. And because of that, I'm going to change how I do the rules. Therefore, I had to round it here. Normally, if I was just going to take this 40 and multiply and divide it by some other number, right, staying within that same family of calculations, I'll just keep that bad boy going. But in this case, I'm going to add it. So that's why I have to change or at least use the difference rules. So 44.03 plus 40, your calculator is not really going to be hopefully too hard. So 84.03, and then based on the rules for addition and subtraction, I'm going to look for the value that has the least precision. This one has the least precision at the ones place, right? Because that one doesn't go any further past that decimal. This one goes down to the hundredths place. So my final answer will be rounded to the ones place, and my final answer for this one will just be 84. So this seems like it's a lot of work, right? It seems like it's not worth the effort of just putting it all into your calculator at once and spitting something out. And the issue here is that you can really start to deviate away from the right answer if you round too much or you don't round the appropriate spots. All right. Let's just kind of, as a hypothetical, let's say we did end up doing a calculation where I stick it all in at once. The resulting calculation from that is just going to be 84.2. This is what comes out of my calculator if I stuck 44.03 plus 103 times 0.39. The calculator will take care of the order of operations for me. But here I'm kind of stuck. Where do I round? How do I round this? And you kind of sometimes get lucky with this, and I definitely wouldn't rely on that. But if you look back here, right? Do I use the 4 sig figs? Do I use the 3 sig figs? Do I use 2 significant figures to round this? Or do I use the 2 decimal places, the no decimal places, the 2 decimal places here to round? Which one do you use? And that's where the confusion can set in if you're not careful. So prevent yourself from getting in that position. Go ahead and just take the step-by-step process of doing this. Remember, this is only really valid or really only used if you have different types of calculations. But if you're staying within the same family, right? If you're staying within multiplication division, you don't have to round every time. Or if you're within addition and subtraction, you don't have to round with every new number that you add and subtract. Okay, and finally here, this is going to be calculations with constants or exact values. So constants and exact values are a little bit different because these are not ones that we measured. We didn't have to use a device and do any kind of estimation. It's just kind of a defined value. So this is one where we saw from a much earlier anyway, is that if we do have calculations involving these, they always have infinite sig figs. And so this is one where you can just basically ignore how it affects your numbers in the end. So how many feet are in 33.24 inches? Now, I'm not going to make you do the work here. Just assume that you can do some calculations. But 33.24, to get the final answer here, you end up dividing that number by 12, right? Because that's basically the relationship between inches and feet. Your calculator will give you 2.77. But here's the deal, right? How many significant figures does 12 have? The correct answer to that is infinite, right? Because we know it's going to be 12 inches per foot. There's not a measurement we have to use to guess at that. That's how it's defined. We know it's exactly 12 inches per foot. So then when we do the calculations, right, this one has 4 significant figures divided by infinite, right? The number of significant figures is how we decide our final answer. So for this one, it ends up being 4 significant figures. So I have to round it to 2.770 there. My calculator might give me just 2.77, but we have to be careful to match the significant figures that our original numbers are given. So it has to be 2.770. On the other hand, you have to determine the average of, or another example here, you have the average of 10.03, 10.12, so on and so forth. So how do you do this? Well, effectively, it's going to be 10.03 plus 10.12 plus 11.92. You divide those all by 3, right? Because that's how you do averages here. Well, if you're not careful, again, some of us might think that this 3 has one significant figure, but that's not the case because 3 is a counted number. There are 3 numbers here that we're adding into the average, and so when you divide by 3, you're really counting or dividing by a exact number. That's an exact value, and so there's no need to actually incorporate that. And to do so, you just basically divide it by an infinite number of sig figs, which shouldn't affect your answers in the end. Right, go ahead and finish these out. You have 6 examples here, just a mixed practice, some of only one type of calculation, some where you blend it up, and you have the answer to double check against there at the bottom. All right, that'll do it.